Hey guys, this is Patrick from STH. Today, we're going to go over the AMD roadmaps basically for 2023 and 2024, and we're going to see some absolutely crazy products. That means that we're not just going to look at like the next gen Ryzen because okay, cool, or the next gen EPYC, okay, whatever, but we're also going to see things like the Radeon Instinct MI300 wild APU, and I'm going to show you why I think this is a super cool product that's going to be coming out in 2023. It's absolutely crazy. And the background for this is that this week, AMD had AMD Financial Analyst Day 2022, where they went through all of the roadmaps and gave an update on the overall AMD business to a lot of the Wall Street and financial analysts that decide how to value the business. So of course, everything in this presentation is going to be great because they want to get the highest valuation that they can, but they also went and talked about a lot of their future products and is basically how they're going to get to that higher valuation and how they're going to make more money, take market share and all that kind of stuff. And if you don't know this about AMD, AMD builds their chips very, very modularly. And what I mean by that is that they basically build like, here's a core and here's our GPU IP, and we're just going to kind of scale stuff based on like, how many chips we have. And they do a lot of scaling with chiplets. And that was really the big AMD innovation, along with the fact that they were using TSMC. So they got better process technology that allowed them to go and make inroads against Intel. So with that, the basic game plan is we're going to talk about the Zen architecture and what was disclosed about that. We're going to talk about the products that use the Zen cores, which is basically the Ryzen as desktop and notebook along with the EPYC line. Then we're going to talk about GPUs, both RDNA for graphics and CDNA for compute. And we'll talk about the products that go into those. And then I want to talk about the embedded space because that has Xilinx and there's a lot of really cool stuff that is going to be coming out of Xilinx. But also AMD started talking about AI finally, which is great to hear. So with that, let's get to the CPUs. Okay, the first bit that we're gonna look at is Zen 4. And you're gonna notice that Zen 4 actually has more than just the single Zen 4 die or core. There's basically Zen 4 with the 3D V cache, and then there's also a Zen 4C. So Zen 4 is going to power a lot of the products that we're going to see in 2022 or later in 2022 and into 2023. That includes things like, the Ryzen 7000 series, but also Genoa, the new processor Genoa-X, which was discussed today, Siena, and also Bergamo. So there's a lot going on here. But the other one is if you look to 2024 on the timeline, you're going to see that there's also a Zen 5. And that Zen 5 has all three of these variations as well. So these are not just kind of like one and done variations that AMD is thinking of doing. In fact, I kind of expect that we're going to see more and more different variations over time. And there's even a couple different variations that we saw if you go and look through the slides with a little bit of detail. We'll get to those when we get there. Okay, so starting with the 2022-2023 generation, we have Zen 4, and that is a 5 nanometer x86 part. Now, AMD is saying they get 8 to 10% IPC improvement, but at the same time, you get somewhere north of 10 to 15% in terms of overall single thread performance. And to get over 15% single thread performance, while you also are only getting 8 to 10% IPC improvement, that means that you have to raise clock speeds because I don't really know any other way to go do that. You get more memory bandwidth, cool, but the big one is definitely this last line. AMD says on this last line that it has AI extensions as well as AVX 512. Now, if you don't know why these things are important, is just the fact that number one, AI is going everywhere, and AVX 512, if you're doing like scientific computing, is just an absolutely, well, it's very good, it's very fast. And we actually looked at this a little while ago, and we have a video on that as well as, you can look at the main site article if you want to too, but we'll link those in the description where we looked at the Intel versions of these because Intel's already been doing this. AMD usually uses a fast follower approach in terms of ISA improvements, and so that's basically what we're seeing here. But when you see the Intel versions of these things, if you do use the AI or the AVX 512, you get absolutely huge performance gains, much more than these 8 to 10% performance gains and IPC gains that you're seeing. You get performance gains, you get lower latency in a lot of cases. I mean, these things are definitely needed, and this is part of AMD's overall AI story that they debuted at Financial Analyst Day. Now, with Zen 5, AMD is saying that it's doing a ground up, it's doing like an all new redesign. AMD really usually doesn't do all new redesigns, even though when they say they're doing all new redesigns, what it really ends up being is that they tend to do larger performance improvement or take, a lot more in terms of doing bigger performance improvement projects. And so I think that that's probably what we're going to see on this one, but you never know. Still, what you're going to see again is that we're going to see another level of AI optimization and engines that are in this. And it's something that Intel is definitely doing as well. We're going to see absolutely massive AI gains when we can show you the Sapphire Rapids numbers. Intel is definitely doing a lot in terms of on-chip AI, and I think AMD is saying, okay, well, we can't have nothing, so we have to kind of follow at least. And I think AMD's strategy is really letting folks develop on maybe Intel and go find what are the applications, what are the areas of applications that can be accelerated with AI on Intel, and then, hey, once all that software kind of foundational work is done, hey, come over and port it to AMD and use our chips. So I think that's basically what AMD's doing. But let's get to the actual products. And first, let's start actually with the notebook line. Now, the Ryzen 6000 series is 6 nanometer, and it's something that's already out. I mean, you definitely go and find that today. But the more interesting one is, frankly, the 4 nanometer one that's coming out. Phoenix Point uses those Zen 4 cores that we just talked about. We also get new RDNA 3, so new graphics. And then you see the AIE. AIE stands for AI Engines. It's actually something that comes out of the Xilinx acquisition. So this might be the first time that we start to see really that kind of integration happen. We're going to talk about more about the AI engines and all that kind of stuff in the embedded and Xilinx part later in this video. So we'll have chapter markers if you want to go check that out. But I think that this is a huge thing because this looks like it's actually an AI accelerator, like dedicated AI acceleration technology that's going into the notebook line. And that's super important. There's a ton of applications that are coming to desktops, whether that's photo retouching apps, but also things just like, recognizing things in video and stuff like that. So I think that we're at the point where using AI inference on edge devices like notebooks, we're definitely using phones all the time. It's just going to be something that's going to happen. AMD has figured that out, and this is going to be their solution, it looks like. So while we have it in the Zen 4 Phoenix Point, it's also in the Strix Point Zen 5 generation, and that looks like it's something that is also going to have a new version of graphics and stuff like that as well. And one other quick thing here, if you look at the node steppings, what they're saying is that, the current Ryzen 6000 is on 6 nanometer, not 7. Instead of using 5 nanometer for Phoenix Point, they're on 4 nanometer. And so it looks like AMD is going to look to take advantage of basically whatever the best process technology they can get, enabling better battery life and stuff like that in the notebook sector. So I think that's actually kind of a cool one. Okay, so let's get to the desktop. Now, AMD has already talked about the Ryzen 7000 series, but you're going to see that there are actually 2 more things in the Zen 4 generation. Not only are we going to have the Zen 4 Ryzen 7000 series, but there's also a 3D V-Cache version. And then you're going to see that there is going to be a Threadripper Zen 4. Woo! Exciting. I love the Threadripper series, so I'm very excited by that. Now, AMD talked a little bit about the prospects for that 3D V-Cache, and it's not going to be something that you're going to see on the entire line. Like, you're not going to see like the 2 4-core processors with that. Like, that's not going to be a mainstream part. Instead, what you're going to see is that really it's going to be kind of a specific part that's really accelerating, certain workloads that can use the extra cache. Frankly, it costs a lot more to actually go and do that extra step. So it's not necessarily for everyone. And AMD said they're not going to bring it out for an entire line, but they're going to have targeted SKU or SKUs for that kind of at that higher end where it makes sense. But if you're looking at that box thinking like, hey, maybe I'm going to have like a $120 3D V-Cache part, probably not in this generation. And then as we move out to 2024, you're going to see Granite Ridge. And that's the Zen 5 part. And, since Intel has Granite Rapids coming on the server side, there's just too many granites. Let's just call it what it is. I wish that they could have more diversity in how they name these things. But apparently we have to all use Granite around the same time frame. So cool, guys. And while the gaming and PC client side is cool, AMD in their financial analyst day is clearly saying, hey, look, the data center is the growth engine for the company. And you can see that even on the roadmaps, because here is the EPYC server roadmap, and you're going to see a lot more going on. We've known about Genoa and Bergamo. We actually have a video on those that you can go check out. But we also now have X, which we would expect. And then this new thing called Siena. Siena is actually really cool, and it makes a lot of sense. We'll go through that in a couple slides. And lo and behold, not only does AMD think that they're going to have a generation for 2022 and 2023, but going into 2024, there's a new Turin generation using Zen 5. So it looks like AMD is planning to stay in the server business. First, let's go back to Genoa, and there's some kind of cool stuff here. So first off, we know that there's 96 cores in Genoa. AMD's been talking about that for a long time. What they haven't necessarily talked about too much, although we've seen some kind of spy images of this and stuff, is the fact that we are going to have 12 DDR5 channels. That's also really important when we get to Siena. We'll talk about that. But the fact is that you get 50% more just DIMM, memory channels. So you get more, potential memory bandwidth, plus you get 50% more cores than you get on the current generation Milan. and you get a new microarchitecture. So overall, I mean, that's a pretty big thing. Now, the one thing I thought was kind of weird on the slide is if you look on the left-hand side of it, it says you get like 75% better enterprise Java performance. And if you're just kind of thinking of this, like just take a step back here. So they're basically saying, hey, we're gonna go from 64 to 96 cores, which is 50% more. Plus, we're gonna get something like an 8 to 10% IPC increase. And that makes it doesn't like really make you just kind of be like, wow, there's going to be like so much more performance per core. But on the other hand, AMD has very high performance cores, and they are adding things like AVX 512 and the AI extensions, which I think are going to be a big deal in this market because Intel is pushing them very hard on the server side. So it is good to see that AMD is actually, doing something about it and not just saying, hey, we just have cores, we have no acceleration. It is something that we focus on a lot on STH because it does give you huge performance benefits when you actually touch those. I do not think that the 75% figure is using all that AI and AVX 512 acceleration. I think that's going to be an adder on top of that. The other huge one, though, is the fact that not only do we get PCIe Gen 5, so we're getting DDR5, PCIe Gen 5, we're getting 12 memory channels, 96 cores, but we also, you can see that we have CXL and the ability to do CXL attached memory. If you don't know what CXL is, it's Compute Express Link. We've done videos on it, even have one with tacos that you can go see. We'll link those in the description as well. But the basic idea with memory expansion is that you can literally take something that look kind of like an SSD. I think at first it would be usually like an EDSFF form factor or something like that, like an SSD. And you basically can plug it in your server, and instead of it being a SSD, like, oh, here's some flash storage, it's RAM, it's memory that you can just add, and you just kind of add a whole bunch of modules. So that allows you to get way higher memory capacities and also allows you to get more memory bandwidth because you're not just limited to, well, I guess in this generation, like 12 memory channels, but you can also start using some of the PCIe lanes using CXL, which is more optimized for those memory transactions, and you can start using that there. I think there may actually end up coming out with this before Intel does, which is actually really cool. Now, let's talk about Bergamo because that one is huge. Now, this is going to use the same SP5 socket as Genoa, and in this, they're going to go up to 128 cores using the space-optimized Zen 4C, which I say is ISA compliant. So you're not going to have to go and make changes to your code to be able to use them. It's not like an ARM port or anything like that. You're basically going to get the same Zen 4 cores, but they're just going to be optimized for more of a cloud computing workload. And the reason that you have these cloud SKUs is because the cloud guys don't really care as much about like getting the most performance per core. They kind of don't care about that, right? Because their workloads are not necessarily dictated by per core licensing. They just need a whole bunch of cores so that way they can split them up, give you, VMs to different users, and that's basically how they're running their business. So AMD is looking at that and saying like, hey, look, if you don't need the highest performance per core, we can do some things to go and change things and give you 128. And if we give you 128 per socket, well, that means that you can fit more in a server, which means that it costs you less to deliver those VMs to people, and then you can make more money, AWS, and everybody can drive around in better and better Ferraris. And this optimization, Intel's going to be doing it with Sierra Forest, so that will happen as well. We're going to see higher and higher core counts. The ARM guys are going to go crazy. Now, you can already get 128 cores with the Ampere Ultra Max, but the big difference with Bergamo is the fact that these are using SMT, and so you get 2 threads per core, which gives you a total of 256 threads per socket. And if you have 2 sockets, that's 512 threads in a single server. Like, wow. Absolutely super cool. Very excited for this. Now, the big new announcements are Genoa-X, which basically, this is 3D V-cache added to Genoa. So you get, your cores, plus you get the extra cache that's been stacked. And so that's something that, we looked at Milan-X. We have a video on that. It's absolutely awesome. I think it's super cool. And I definitely think that if you can get it, I really like the feature. So I think that's a great feature to go get. About a year ago, we talked about the Gigabyte era, and we're totally going to get there with this, and also Intel with Sapphire Rapids HBM is going to end up in the many, many Gigabyte era. So definitely seeing Gigabyte era CPUs with this generation in 2022. Okay, Siena is really cool because you're going to see that there's like this cost optimized and like embedded and like all that kind of stuff there. You have to remember this is a financial analyst day, but I'm going to kind of give you an idea in terms of why the presentation kind of showed it like this, but I'm going to give it another thought on what it is. So what you can see is this is 64 cores maximum, but it's a smaller, I guess, chips, but it's also a lower cost platform. Here's the deal, guys. When you have a big platform, like the full SP5 platform with 12 DIMMs, you have PCIe Gen 5, it's super expensive to go produce those. Now, at the high end, if you have a 96 core, 128 core CPUs, you got tons of memory, all that kind of stuff, then it's really not like a huge cost, the extra cost for the motherboard. But oftentimes, these motherboard costs can be $100, $200 more. And when you get to the lower end of the segment, like lower end of the market, when you have like a $1,600 server or something like that, adding $200 becomes a big deal. And so there are other parts of the market that don't necessarily need that maximum density. And the fact of the matter is that the new chips from AMD are kind of becoming too big for those segments. I mean, they literally have chips that are going to be too big to go and like, you know, you're not going to want to have like a low cost 64 core, 32 core, 8 core, 16 core server. You're going to need something else. AMD already ran into this problem, and so they had things, we did a video on like the 4-channel optimized AMD SKUs, but then also when they launched Milan, some of the really low-end SKUs, they didn't transition to Milan right away. They said, no, just keep buying the Rome parts because those are better optimized for the low-cost platforms. And that's why, especially in the early Rome days, we saw people putting like the kind of lower-end chips in the EPYC 7001 Naples platforms because they're like, hey, look, we're not going to use PCIe Gen 4 in this generation. We just need something less expensive. And the PCIe Gen 3 motherboards are maybe $200 less. So we're going to just use the older platforms because that's what we need. The same thing is going to happen when you get to bigger and bigger servers. And that is exactly why Siena is a super important product. All right, let's get to GPUs because everybody always likes GPUs. And we're going to basically move from RDNA 2 to RDNA 3. And then we're going to go to RDNA 4. With RDNA 3, we're going to go to 5nm, but also AMD says that we're going to go to advanced packaging technology. So I think we're going to see chiplets. And AMD is also doing their overall corporate theme of adding more cache by looking at the Infinity cache on this as well. So new RDNA GPUs for consumers and gaming and stuff like that, that's cool and all, but like really the big one to me, at least, is CDNA. Now, if you don't know, AMD split their graphics or their GPU division into basically the RDNA for, you know, kind of desktop graphics and things that you kind of use a GPU for if you're like you're touching a system. But then on the other hand, they have CDNA, which is really kind of more of the compute focus. So these are the ones that if you're going to go run them in a supercomputer like Frontier with the MI250X that we looked at a bunch, you can definitely look at those and say like, hey, those, they don't really need a graphics pipeline because they're just number crunching. So AMD said, yep, it's time to go and split the line and we're going to go make optimizations for both. But what AMD is doing with the next generation is just amazingly cool. So with CDNA 3, AMD is saying, hey, we've already split this and we're now making a GPU specifically for compute. It's really a compute accelerator. And with that, we don't necessarily need to go think of things like, hey, how do we go put HDMI or DisplayPort outputs on this thing or any of that kind of stuff. Instead, we can just kind of focus on what are the applications that we need for compute. So AMD is talking about things like their new Infinity Fabric architecture, but they're also talking about, if you look at this diagram, well, basically you have an APU. You have CPU dies, you have GPU dies. Underneath, that's actually in the cache type of thing, so that's actually a cache. And then you have HBM memory on the sides. So basically, for the high performance computing thing, this is like scaling up, I don't know, like a notebook GPU or something like a bajillion times. So if you look at Frontier, this is kind of a little bit of an abstract way to think about things, but the way that they basically have set up is you have a Trento CPU, which you can think of like as an 8CCD AMD CPU, and then each CCD, so each 8-core, CCD, basically is connected to an MI250X, but like half, because the MI250X is kind of like 2 GPUs on a single package. So basically what they have done is they said, look, we're gonna have like 8 cores feeding a GPU, but we're gonna package it up in like 4 different OEM GPU packages plus our CPU socket. With the MI300, they're saying, hey, that's stupid. Let's just go and make a real APU. Now, putting this together, they have the new Infinity Architecture, and basically the Infinity Fabric for AMD started out and it was basically like, hey, here's PCIe and we're gonna go put our own protocol on top of that, and that's our Infinity Fabric. That is a gross simplification, I know, but it is pretty much what's going on. And with their 4th generation, they're looking at things like being able to integrate third-party IP, which could be Xilinx. It could also be, chiplets that cloud providers or somebody else wants to go put onto a chip. There are things like the ability to do 2.5D and 3D stacking. And then kind of interesting thing is not only do you have CXL 2.0, but you're also looking at the potential of 3.0 and also UCIe. CXL 3.0, I don't think is actually officially the name yet, but it's what everybody uses in the industry at this point. And we just did a piece on UCIe which is basically a chiplet solution where the industry is kind of getting around doing chiplets. And pretty much all the big vendors now are saying, okay, we're going to be doing chiplets and we're going to be using this thing called UCIe to start doing that integration between the different chiplets on a given package. And so it's kind of cool that AMD is going to be supporting that, but we would kind of expect it. But when we look at how they put it into the MI300, we basically get a couple of different components. And you got to look at this line right here, which basically says that we have not just our Zen 4 CPU cores and our RDNA 3 GPU cores, but we also have HBM and cache. And the reason this matters is that instead of having copies of data in both like DDR4, now DDR5 in the next gen, DRAM, as well as having it in HBM for the GPU. So instead of having like CPU and GPU having their own memory, you go to a unified memory architecture. And this is very similar, by the way, to what Apple does with their like M1, M2 chips. It's basically the same idea. It's just AMD is scaling that up to like really, really big. Like, this is going to use a lot more power than an M1 or M2 chip, I can tell you that. And the other thing that AMD is doing is that they're doing more integration with more different dies. And you could see the other thing I just think is really crazy is the fact that you can look and you can see the fact that they have the Infinity cache there too. So they have caches for the different chiplets as well as the HBM. And that just kind of seems like they are trying to optimize and move data around as efficiently as possible. And moving data around in supercomputers is super expensive, uses a ton of power, and causes a lot of latency. So this is something that is absolutely great. Okay, GPUs are super fun, but let's talk about the FPGA side and embedded side. With the Xilinx acquisition, not only did AMD get a bunch of revenue, but they also have a leader really in the FPGA space. FPGAs are used in the embedded market all the time, and it's a different kind of business. So now AMD has a kind of class-leading solution that they can also sell things like their Ryzen and APUs and stuff like that through as well. So I think it's actually super cool. Xilinx was also working and saying like, hey, we're going to be data center first, and that was like a big push for Xilinx. So I think there's some synergies there. But what the other thing that they're doing is that they're using some of the Xilinx IP to go do those AI engines that we talked about previously. So it looks like Xilinx actually is kind of like AMD's idea for like, okay, what's our story on AI? And I think a lot of it actually comes down to Xilinx. Now, if you don't follow us on the STH website, FPGA, the kind of like time between things when things get like announced, when they're available and like released, and like the lead times on these things are crazy, and the design cycles are long. The markets, these things are designed to be out there for 7+ years in the market, right? So it's just kind of a different market than the CPU side. So we're going to go from 7 nanometer. There's not going to be a 5 nanometer generation. Instead, they're going directly to 3, at least according to the roadmap. Now on the EPYC side, you're going to see that there's an EPYC embedded. I've looked and I can't find anything like an updated EPYC 3000 series. And so I don't know what to tell you there, but there's apparently a 7 nanometer EPYC embedded. I think what it might actually be is like the big, EPYC chips, like the Rome Milan chips, and those things being used and embedded or in lower power, I guess. Maybe that's what it is, but I think that is something that Siena is going to start taking out. But apparently we're going to get 5 and 6 nanometer x86 embedded parts as well. The big one though is just, let's get to the AMD XDNA. So they basically have rebranded a lot of the Xilinx stuff XDNA. And the big one here is the fact that Xilinx had this idea where instead of just having programmable like FPGA, logic, and then putting that on a fabric, they could instead also, or in addition, have the AI engines. And these are basically dedicated AI accelerators where you have the little, math part next to its own little bit of memory. And then you have a fabric where you can go and, push different routes through this whole array. And so when we see in some of the products where they're using AI engines, that's really this acceleration block that Xilinx is using, and they're using it for things like beamforming and stuff like that on like 5G wireless radios and stuff like that. But this is really something that's a little bit different, and they're really saying, hey, we can use this technology and go put it into our Ryzen chips and call it the AI engine. And I just thought that's super cool. The other thing though is that AMD has said, hey, we realize that software-wise, we're not in such a good spot right now because we have all these different stacks. We have like the GPU stack, CPU stack, and then we also have our stack for Xilinx. But instead of having 3 different stacks, what the idea is that they're going to have a unified AI stack, and that unified AI stack is eventually going to go so that way a front-end developer can just go and program, and then whatever AMD device a application lands on, they'll be good. There's also, everybody else is doing this too. NVIDIA's doing it, Intel's doing it. Everybody in the industry wants to do this because nobody wants to have AI acceleration in every kind of chip and have like 300 different versions of like SDKs and stuff like that to go kind of work through. Nobody wants to go do that. So at least folks are starting to do that in their own silos at their own companies. But it would be nice if like you didn't have to go do that whole step, right? Cool. So anyway, that's a look at all the cool stuff that AMD has coming out. I'm super jazzed for later this year, if these darn chips can finally get out so we have the new generations of stuff to review. I can't wait. But, I do think that the other thing is that these chips are getting a lot bigger, a lot more power hungry. And so there is a gap in the market, or there will be a gap in the market between kind of the desktop parts and then also the very high-end server parts. And I think that's going to be a really interesting battleground for both AMD and Intel going forward, as well as some of the new ARM players. Well, we have a ton of content coming out for this, so if you like this video, why don't you give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.